Track 34. I'm going to start this lecture by describing the structure of an offshore oil rig. Well, to be accurate, we should call it an oil platform. If you look at the diagram, you can see the top part of the platform floating on the surface of the water. The tall tower in the centre of the platform is called a derrick. That's D-E-R-R-I-C-K. The derrick is where the drilling machinery and lifting equipment is installed. Okay? Now, if you look about halfway down the diagram on the right, you can see a helicopter. It's parked on the helicopter pad. Helicopters are used mostly to transport employees to and from the platform when they have free time. Now, if you look underneath that, at the very bottom of the platform, you can see one of the 4 support towers. These support the rest of the platform. These metal structures are usually attached to the seabed by long cables. Right. Now, the last part of the platform I'm going to describe is on the other side, just above the level of the water. It's a crane. That's spelt C-R-A-N-E. Cranes are used everywhere in construction, but this one is specialist equipment for lifting heavy spare parts at sea. In fact, apart from the derrick, you can see 3 cranes in the diagram. Track 35.
Some experts believe that if we knew how to control the power of the sea, we could generate enough electricity for the whole world. But, in this talk, I'm going to focus on the UK and our capacity for generating electricity from wave and tidal energy. I'm going to look at how many megawatts we generated before 2008 and how many we expect to produce in 2014. So, if you'd like to look at the chart, you'll see that before 2008, our capacity was only 1 megawatt. But in 2008, when oil prices rose, there was an increased interest in marine power, and our capacity grew quite dramatically to 4 megawatts. Now, you might have expected this figure to rise consistently over the years, but, in fact, it dropped again in 2009 to only 2 megawatts. This was because oil prices fell again, so there was less interest in developing alternative power sources. But nowadays, the cost of oil production is going up again, and there's been a renewed interest in marine power. As a consequence, capacity has increased steadily since 2009, reaching 18 megawatts in 2012. This trend is expected to continue in the near future, reaching a total capacity of 50 megawatts in 2013 and 60 megawatts in 2014.
Track 36. Section 4. You will hear a lecture on deep-sea exploration. First, in the exam, you will have 20 seconds to look at questions 1 to 4. Listen carefully and answer questions 1 to 4.
Good evening. My talk this evening will cover 3 main themes. First, I'll outline a timeline of how deep-sea exploration vessels developed. Secondly, I'll describe the most recent of these, the Deep-Sea Challenger. And finally, I'll look at some of the benefits of this deep-sea research. OK, to start with, let's look at how underwater exploration vehicles have developed over the years. The first manned deep-sea exploration vessel was invented in the 1920s. It was called a bathysphere, better known as a diving bell. It was basically a round metal structure with windows with just enough room for 2 men to sit in. And it was lowered into the ocean on a cable. The first descent in the diving bell took place in 1930, and in 1934 it went down to a depth of nearly 1,000 metres, which was impressive for the time. The problem with the diving bell was that it had no power of its own, and there wasn't much room for the researchers to move around. So, The next development after the diving bell was the bathyscaphe, a small manned submarine invented in the 1940s. The difference between the two was that the bathyscaphe had its own power source, which allowed the scientists to investigate in the depths of the ocean more freely. A bathyscaphe called the Trieste reached a record depth of 10,000 metres in 1960. Since then, a new record has been set by James Cameron, who descended to a depth of 11,000 metres for the first time in 2012.
Before you hear the next part of the conversation, in the exam, you will have 20 seconds to look at questions 5 to 8. Track 37. Listen and answer questions 5 to 8.
So let's move on now to look at the submarine that took James Cameron so far down into the ocean. If you look at the drawing of the Challenger, you can see the pilot's chamber at the very bottom of the submarine. It's a very small section where the pilot sits and controls the sub and all the equipment on it. Now let's have a look at how the submarine is powered. Going up from the pilot's chamber, in the middle of the sub, on the right-hand side of the drawing, you can see a whole section covered in batteries. They provide the power source that takes the sub all the way to the bottom of the ocean and back up to the surface again. Next to that, there's another important part of the sub. You probably realise that there's no light at the bottom of the ocean, so the sub needs to take its own. If you look at the back of the sub, in the middle, just next to the batteries, you can see the panel of lights. They provide the light for filming and taking samples from the seabed. And one more part of the sub, which is important for navigation and to stop it spinning out of control, is the large fin at the back. You can see it at the back of the sub at the top of the drawing.
Before you hear the rest of the talk, in the exam you will have 20 seconds to look at questions 9 and 10. Track 38. Listen carefully and answer questions 9 and 10.
OK. To conclude my talk, I'm going to ask a couple of questions. First, what is the purpose of this deep-sea exploration? And second, is it worth the expense? I think one of the justifications for spending so much money on this kind of research is that it allows scientists to understand more about the surface of the Earth. For example, how it was formed and how it behaves. This could have important consequences for predicting earthquakes and saving lives through early warning systems. Another reason this type of research is considered valuable is that by exploring unknown parts of the ocean, we increase our knowledge of the availability of minerals for industry. And obviously, this could lead to huge commercial advantages. So the answer is yes. In the long run, this kind of exploration can benefit both the ordinary population and industry.
That is the end of section 4. In the exam, you will have half a minute to check your answers.